More and more children are out of school, but parents don't want math learning to stop. They're turning to Mathnasium at Home. Real-time math instruction tailored to your child's exact educational needs. It's the same face-to-face live instruction used in our centers for over 15 years, now on a computer. Your child can keep their math skills sharp, catch up, or soar ahead, from home or anywhere with an internet connection. To learn if Mathnasium at Home is right for your child, visit mathnasium.com/at-home. Mathnasium at Home, changing lives through math.
Hello everyone, and welcome back to the Mathnasium Schoolhouse. I am John, the AVP of Education and Training for Mathnasium, and I am joined here today by my friend Diophantine that you see on your screen right there. And if you studied as much math as I have, then they're all your friends at a certain point. The title of today's session is a little bit weird, and I want to focus on something called the water jug problem. And what's cool about that is if you're a parent or if you're joining us from a Mathnasium Center and you're looking for something fun to do with the kids when they join you, this is actually a kind of a cool experiment to do. And I want to talk about the math behind it. And while these Diophantine equations are something that you study much later in your math life, probably when you go off to college, you actually study them kind of all along. Maybe they just don't give it a name. And you actually, with kind of some math that you've learned, in elementary school, you know enough math to understand it, which is kind of cool too. So for those reasons, I just think it's a cool topic to talk about, and it has some interesting history around it. Diophantine lived about 1,800 years ago. He wrote something called the Arithmetica, and in that book, in that text, what we call the Diophantine equations were prominently part of it. And there are some, there's also something cool that's called Diophantus's riddle, which you can look up later, which allows you to use some basic algebra and calculate how long he lived. And I'll add that to the worksheet that you get later on. So, it's just an interesting topic with, an interesting history around it. And I mentioned that you may have seen some of these things and you just don't realize it. So in the comments, I hope that you all introduce yourselves and where you're from. If you're from at a Mathnasium, what Mathnasium you're at. But that first one, what do we call that? So we know that if you've seen it before, we think of that as being the Pythagorean theorem. And we call it the Pythagorean equation here. When we're talking about these types of equations, what we're interested in are what we call integers. We know what integers are. They're positive and negative whole numbers, and don't forget about zero, that make that true. And maybe your teacher, if you've learned somewhere about the Pythagorean triples, like if A is 3 and B is 4 and C is 5, it works. Or if A is 5 and B is 12 and C is 13, that works too. We call those Pythagorean triples, and those are an example of a Diophantine equation, which is kind of cool. So if you've seen the Pythagorean theorem, you've actually kind of seen this. We know that some other things solve the Pythagorean theorem. You get some square roots or irrational numbers. But when we have just integers like the Pythagorean triples, that's kind of a case of this. The other one I mentioned this because if you want to look up things later, or if you're a parent and you want to look up some things and share them with your child, Fermat's last theorem is, certainly a critical part of this. And you're looking at something that, as simple as it seems on the surface, was probably the most tried and attempted and failed theorem to be proven in history. It actually took the greatest mathematical minds attempting it and failing at it. And it took about 370 years for somebody to actually prove that basic, seemingly simple equation doesn't have a solution if n is greater than 2. The exponent is larger than 2, which is cool to think about. So just a couple things and connections and something to look at later if you have an interest. And like I said, what we're going to talk about today is a very easy experiment to do at home if you have some containers and water. I wouldn't use something like Hawaiian Punch or anything like that because you probably will spill something. But let's dive into the lesson. So I have a problem there, and this is the problem that we're going to build up and work on solving. I'll give you a moment to read it. And yes, those rectangles are jugs. I'm not great at drawing jugs, so we're going to have to pretend that that's what those are. And this one is a little bit tricky. And this is where you can start to think about how an experiment would work. And they don't have to be gallon containers. They could be like a coffee mug and a coffee cup that have different ounce measurements, and you can create problems around it. But the goal of this is always the same. I have two unmarked, in some variations you have three, but in this case we'll deal with two. We have two jugs, one of different sizes. They're unmarked because you may say, John, if I want 4 gallons of water, I'll just fill it up till the marker says 4 and I'll stop. But they're unmarked. You have no way to measure it other than you can fill them up, you can pour them out, and you can pour them from one to the other. And there's a rather simple mathematical reason behind, and the solution to this has something that we're going to explore mathematically. So that's the goal for today. We'll solve it at the end if you stick with me to the end, and it should be fun. So as always, I want to just talk briefly about review what it is that I would need you to know. We need to kind of know basic multiplication, and more specifically multiplication that has negative numbers in it. So if I were to ask you what 2 times negative 3 is, and you should get negative 6. We know positive times a negative is negative. And we're not going to deal with multiplication. They're not going to be huge numbers. We're going to deal with very small, pretty basic multiplication facts. But we do need to know how to deal with negative numbers, negative integers here in this lesson, okay? I kind of need you to be able to help me fill in the blanks a little bit in something like that. So kind of a missing factor problem. So what number would I put in the blank? 4 times what number is equal to negative 8? So hopefully you got negative 2. And if you did, that's awesome. And not so bad. Like I said, not going to be huge numbers today. It's going to be kind of small multiplication. The other one, and this is sort of tricky, but not so bad if you take your time, I want you to be able to simplify things like this for me. So if you studied, maybe I'll even throw some parentheses around that just to help a little bit, just to separate them. Basic order of operations stuff. So the question is, if I multiply 1 times negative 2, what do I get? Negative 2. And if I multiply 4 times 3, what do I get? That's not so bad. And then I need you to be okay with what negative 2 plus 12 is, and you get 10. So negative 2 plus 12 is 10, or you can think of it as being 12 minus 2, either way. So like I said, if those things are tricky or hard for you, then follow along, take notes on your paper, and watch this video again and go through it, and you'll be okay. So those are the things I kind of need you to be able to do. All right. So that said, I'm going to give you just a moment, and I would like you to try to fill in the blanks. So I want you to fill in the blue blank and the green blank with numbers that make that statement true. Let's see what you get. You can type them in the comments if you'd like. And what we're looking for here, remember, we're looking for things that are integers. So you can fill that in with a positive whole number, a negative whole number, or even zero. And zero is okay too. So here's an example of something that works. And I just want you to tell me if you, well, I told you that it works, and now you know it's true, but I want you to check it for me. So if I put in a 2 there and a 1 there, is that true? So 2 times 2 is 4, plus 1 times 1 is 1, and that is true. 4 plus 1 is 5. Now some of you may have found a different answer, a different solution. And that's what's cool about this, is that there are actually, in this case, an infinite number of things that work. You can keep trying to find them all and you won't be able to. There are an infinite number of things that work. There are plenty of examples that are true. Okay. So some of you may have said, well, I'll keep it simple. 2 times 0 is 0, plus 1 times 5 is 5, and I get 5. And that's perfectly fine. If you're good with negative numbers, you might have said, well, 2 times 3 is 6, and 1 times -1 is -1, and 6 minus 1 is 5. And that works too. And I can keep going on and on and on. And in terms of the math today, that's about as hard as it's going to get. So not so bad. And it's actually makes it easier if there are a lot of things that work. You know, sometimes it's hard if there's only one thing that works, but in this case, there's a lot of stuff, which is great. So before we move too far forward, I'd like you to try another, and I'm going to give you just a moment to think about that. And I'd like you to, again, try to fill in the blanks. And in this case, I want you to try to find more than one. So challenge yourself to find 2 different answers, 3 different answers. See what you get. Okay, so there's a lot of different ways this could work. You can think of it as being 3 times 2. So I'll put in a 2 right there, plus 2 times 3. So I put in a 3 there. Make it 6 plus 6, which is 12. Okay. I could say 3 times 0, because remember, we can use 0 if we want. 3 times 0 is 0. 2 times 6 is 12. So 0 plus 12 is 12. And what's really cool to think about, and depending on how old you are, and some of you might be young, and some of you might be kind of in elementary, middle school, but when you're solving problems like this where you're filling in the blanks, you're actually doing algebra. Because in algebra, all we do is we put variables in those blanks and we look at it in a different way. So anytime you see like 3 times what number, when we're trying to find what number, a lot of times we're just thinking of it, it's algebra. We just give it a different, we give it a letter and a procedure later. So you're kind of doing algebra here, which is interesting to think about too. Okay, so now you can practice this, and parents, you can set these up, take missing factor plus another missing factor, and this is an excellent thing for them to practice, and it stretches their brain beyond basic multiplication facts and practicing multiplication all the time. You can do 10 of these, and it's interesting to think about all the different ways this could work. Okay, so this is something for you to practice. So now what I want to do is I want to start connecting it to the original problem, which was I have these 2 containers, these jugs, and remember my rectangles are jugs. Think of them as being something I can put water in. So I have 2 jugs. One of them is 2 gallons. The other one is 5 gallons. And I want you to tell me what steps you would follow. Remember, you have a faucet, and you can fill up, use the faucet to fill them up. You have a sink that you can dump the water out in, and you can dump them one into the other. All of those are fine. You think about it like an experiment that you would do. And I would like to know what the steps would be, like step 1, step 2, step 3, step 4, to take those 2 jugs and get exactly 4 gallons of water. But as you're thinking about that, and I'll give you just a moment to think about it, I want you to look at what I did here. I gave you something here that looks exactly like what we were just solving. And remember, I said a moment ago that that's about the ones we were doing were about as hard as the math would get. So it's not a coincidence that I have a 2-gallon and a 5-gallon, and I'm trying to make 4 gallons. They're connected in that way. Okay? So when you're thinking about how to connect this experiment to the math, you set it up in the exact same way. Okay? I did that for a reason. Now this one isn't so bad, and I started with one that's not so bad because I want you to not be focused too much on the water and dumping it and it's pouring it. And think of it this way: if I take that 2-gallon container and I fill it up all the way to the top, okay, and so step 1 for me would be fill the 2-gallon container. And then what I want to do from there is I want to take and dump that into the 5-gallon. Okay, so now I have 2 gallons in my 5-gallon container, and my 2-gallon container is empty. Well, then I'm going to do it again. I'm going to fill up my 2-gallon container to the top. I'm going to pour it into my 5-gallon. Step 4, dump that into my 5-gallon. My question is now, how much is in my 5-gallon container now? And hopefully you recognize that there are 4 gallons in there. I dumped 2 gallons into that 5-gallon container twice, and now that 5-gallon container has 4 gallons in it. Okay. But I want you to, if you looked at the equation that I had below and you filled in the blanks, I'm going to ask you, is this true? Well, 2 times 2 is 4, plus 5 times 0, which is 0. 4 plus 0 is 4, and that is true. Now my question is, how many times did I fill up the 2-gallon container? I filled it up twice. And how many times did I dump out completely the 5-gallon container? I didn't do it at all. Okay. Well, that's interesting. Something for you to think about. Let's take a look at another one and see if there's even more of a connection between the problem and the equation that we solve here. Let's keep that in mind. So let's say you had the exact same 2 containers, a 2-gallon and a 5-gallon. How do I get exactly 3? Think about that for just a moment. I'll give you a sec to think, to work on that. And you can also think about if you're having a hard time figuring out how to pour from one to the other and keep track of that, you can solve the equation at the bottom. And I'm going to show you how they're connected. Because if you can solve what's at the bottom, you actually have the answer. You just haven't realized it yet because you haven't done this enough times. Okay? Step one. Now on this one, I'm going to start differently and I'm going to fill up. So hopefully maybe your step one was I'm going to fill up that 5-gallon container first. Okay. And sometimes it's helpful to think of this in terms of a table. So I'm going to put a little table here to help you keep track. So I have a 2-gallon and a 5-gallon container. And my first step was I filled up the 5-gallon first, which means that I have nothing in my 2-gallon container and I have 5 gallons in my 5-gallon container. Step two is I'm going to take everything in this container and dump it in there. So dump the 5-gallon into the 2. So when I do that, I have 2 gallons now in my 2-gallon container, and I have 3 in my 5-gallon container. And just think about for a second why that's true. Because I had 5 gallons to start with, I poured 2 out, so now one container has 2 and the other one has 3. And remember, I want exactly 3 gallons of water. So I'm going to dump out, my step 3 is I'm going to dump out my 2-gallon completely. Now I have nothing in there. I have 3 in my 5-gallon container, and I'm done. I wanted exactly 3 gallons. I have 3 gallons in my container. But I want you to focus on the connection between this example and the math equation that I have at the bottom. So my question to you is, how many times did I dump out the 2-gallon container completely? I did it once. And when I dump out a container, I think of that as being a negative number because I'm taking it away. So I'm going to put a -1 there. And my question now to fill in the second blank is, how many times did I fill up the 5-gallon container completely? And the answer is once. I did it at the very beginning. I'm going to put a 1 there. Is that equation true? And the answer is yes. 2 times -1 is -2. 5 times 1 is 5. -2 plus 5 is 3. So what that means is if you can solve this and kind of fill in the blanks as we have been, then you actually are finding the steps. Then you just have to put the steps together. If I fill in the blank with a positive number, that tells me how many times I filled up that particular container completely. And if I fill in the blank with a negative number, that tells me how many times I dumped that container out completely. And you're starting to see how the experiment works. And you can use 2 different containers of water, and you fill them up completely or you dump them out completely. But when you set these up with your child, it will tell you how many times you fill it up and dump it out to make it work. And what's cool about this is that there are actually an infinite number of ways to do this too, which means that this is not the only answer. It's something to practice. So if you're having a hard time figuring out all the steps, You can solve the equation, and that will tell you how many times you have to do each, and then you just have to figure out in what order the steps go, which is kind of cool. Okay, last question of the day. So let's go back to the original problem. I have two containers. I have a 3-gallon container and a 5-gallon container. How do you get exactly 4 gallons of water? They're unmarked. They don't have little notches that say, okay, I'm going to fill it up to 4 gallons and I'm done. So I'm going to give you a moment to try to solve this one out. Think about what, where is that? Think about what the equation would be. Because remember, if you're having a hard time figuring out, remember, I want 4 gallons. If you're having a hard time figuring out, well, what step would I do first and what would I do second and which one would I fill up? Remember, if you solve the equation first, it will tell you how many times I would have to either fill up or empty the 3-gallon container and how many times I would have to fill up or empty the 5. And if you're a parent, or like I said, a mathnasium center that's looking for a cool experiment to do, if you have containers that will help you set up the equation, the kids can solve the equation in multiple ways, and then you can practice putting all the steps together and measure what you have at the end. And it should be exactly what you expected it to be. The equation that you're trying to kind of solve here is this. If you can fill in the blanks, then you have exactly what you need to do. If you're setting up an experiment at home, you have exactly what you need to do, and then you just have to practice the pouring. Okay. And as you're thinking about it, the only things that matter are filling up the container all the way and emptying it out all the way. If you're pouring from one container to the other, that does not count here or here. Transferring the water from one container to another doesn't count. And the reason being is that I'm not increasing the amount of water that I have between the two containers, and I'm not decreasing the amount. If I pour from one container to the other, the amount of water that I have is exactly the same. Okay. So there's a lot of ways to look at this. And if you filled in the blanks and solved it, then you found a bunch of different ways, depending on what you did. I'll take a look at an example where I will plug in a -2 here, and I plug in a 2 here. Get rid of that. My question to you is that true? Because before I start, I have to make sure that I set up a true equation. 3 times -2 is -6. 5 times 2 is 10. -6 plus 10 is 4. So what that means is if I fill up this 5-gallon container in full twice and I dump this 3-gallon container out twice, that's what I need to do. And then I just have to figure out in which order makes the most sense. Okay. And as you're practicing it, there's actually a logic behind which you should do and when. And that's something to kind of talk to your child or think about as you're doing this. Like what should I do and when? Okay. So step 1, I'm going to fill up the 5-gallon all the way. which means that after my first step, I have nothing in my 3-gallon container, and I have 5 gallons in my 5-gallon container because I filled it up all the way. Okay. My next step is I'm going to dump the 5-gallon into my 3. Okay, so if I do that, I have 3 in my 3-gallon container because I'm going to fill that up to the top. And I have 2 in my 5-gallon container because I started with 5. I dumped out 3 into my other container, which means I have 2 left. And remember, our target is 4 gallons, so we're not there yet. And if I solve that equation first, I know I'm not there because I know I have to do certain things in order for this to work. Okay. I'm going to dump out the 3-gallon container completely. And take that 3-gallon container, I'm going to dump all the water out into the sink. Means I have nothing left in my 3-gallon container, and I still have the same 2 gallons in my 5-gallon container. Okay. I'm going to take the 2 gallons that are in my 5-gallon container, and I'm going to transfer them over to my 3-gallon container. So I'm going to dump the 5-gallon into the 3. So now I have 2 gallons in my 3-gallon container and nothing in my 5-gallon container. So I just transfer that. I dump the water from one to the other. I'm going to erase this to make more room for myself. My next step is I'm going to fill my 5-gallon container again. So now I have the same 2 gallons in my 3-gallon container, and I have 5, I filled it up. Okay. And you're starting to see how this comes together. Because remember, my target is to have 4 gallons of water. Right. I'm going to dump my 5-gallon into my 3. But my 3-gallon container has 2 gallons in it, which means it has only room for 1 more. So I fill that up, which means that I'm really transferring 1 gallon from one container to the other. Now remember, I only wanted 4 gallons of water total, so my last step is actually going to be to dump out the 3-gallon completely. And I've met my goal of starting with a 3-gallon container, a 5-gallon container, unmarked, and ending up with exactly 4 gallons in my 5-gallon container. I have nothing more, nothing less. Now remember the connection between the steps and the equation. The equation tells me that a solution to this is to completely fill up the 5-gallon container twice, which I did. And it tells me to completely dump out my 3-gallon container twice, which I did. I dumped it out once there, and I dumped it out once in the end, which is what I would have expected. So as I mentioned, if you have containers, you can set up the equation, you can think about the steps, you can transfer the water, but if you solve that first, then that tells you exactly how many times each of those things should happen. And this is not the only solution to that. And I will leave that to you as a challenge to find another solution to that. Maybe there's an easier way, or maybe it's more complicated. Okay? But it's something fun for you to practice at home. Don't waste water. Use small containers and dump it into a bowl and then water a plant or something. But I hope you have fun with this. All of that said, I think I'm going to leave you with that today. I hope you enjoyed it. I hope you practice it. I hope that you have run a fun little experiment and explore this idea around these equations and this water jug problem, because you know all the math. It just takes practice. Mathnasium Schoolhouse is always here Monday through this next week. We'll be here Monday through Thursday at 11 a.m. Pacific. As always, I appreciate all of your hard work and your nice comments, and I hope to see you again soon on this. Enjoy your weekend, and thanks again. Talk to you later. Bye.
It's afternoons that seem to be the most hectic for us, so it was much more convenient when we found Mathnasium at home.
All right, so how do we do half of 5? I think one of the best things about at home is that it really feels like you're almost at home with the student in their house teaching them.
I'm in my comfort zone.
You can just ask for help and the instructor will come right to you.
With Mathnasium at home, I know that they're getting the help that they need.
Awesome, great job.
Mathnasium, changing lives through math.